Now in the sufficiency part, we are going to prove that if any test satisfies condition A, condition A is related with the size condition and condition B gives us the form or the structure of the test. So if any test satisfies condition A and condition B for some constant K, then it is most powerful for testing P0 against P1 at level alpha. So if we assume that test phi satisfy condition A and condition B for some constant K alphas, then the test phi will be most powerful test. So अभी वो हम लोग प्रूव करने की कोशिश करेंगे. That is nothing but the sufficiency part of the NP lemma. So here, as I said, condition phi is going to satisfy condition A as well as condition B. That is what we are going to assume. And we wanted to prove that the test phi, which is satisfying condition A and condition B, is most powerful test. So अगर मुझे प्रूव करना है कि टेस्ट phi most powerful है, then the prove that particular part, we have to consider any other alpha level test. Okay, and then we will calculate the power of phi of x and any other test which we have said that is alpha level test. We'll compare the power of both the tests, and if power of phi of x is greater than equal to power of any other test, then we say that phi of x is most powerful test. So this is the way we are going to prove whether the given test is most powerful or not. So that is what I have written here. Let phi of x be the test having, or satisfying condition A and condition B, and let phi star x be any other test such that expectation of phi star x under H0 is less than equal to alpha. So the meaning of this particular condition, that is expectation of phi star x under H0 less than equal to alpha, means that this phi star is any other alpha level test. So it means that we have now two tests, phi of x and phi star x. Phi of x satisfy condition A and condition B. That means phi of x is also alpha level test and it has some structure, right, given by B. Phi star also satisfy this condition. That means phi star is also alpha level test. Now, if we want to show that phi is most powerful test, then we should compare the power of phi of x and phi star x. And then depending upon the situation, we can say that phi is most powerful test or not. So that is what we wanted to show that phi of x is most powerful test, that is power of phi of x greater than equal to power of phi star x. अगर हम इस तरह से प्रूव कर सके, that is expectation of phi of x under h1 greater than equal to expectation of phi star x under h1, अगर इस तरह से प्रूव कर सके, then we can say that phi is having a maximum power among all alpha level tests. That means phi of x is most powerful test. इस तरह से हम लोग प्रूव करने की कोशिश करेंगे. ओके, now to prove this particular part, we are going to consider a sample space, that is script x or sample space S. We will divide this S into three subsets or three subsets denoted by S plus, S minus, S naught, right? Be the sets in the sample space such that S plus कैसे define कर रहा हूँ, देख लो. S plus is equal to all those sample values such that x of course belongs to S, because S plus is a subset of S. So S plus has to, must belong to S, and where phi of x minus phi star x is greater than 0, right? So this is the way we are going to define S plus. S minus is defined such that all those sample values which of course belongs to S such that phi of x minus phi star x less than 0, right? So this is the second subset, and in the I think this should be S naught, huh? So someone should take a screenshot, huh? नहीं तो final notes में ये गलत आ जाएगा. This should be S naught. Now how S naught is defined? S naught is equal to all those values of x, of course, which belongs to sample space S, such that where phi of x minus phi star x equal to 0, right? So three simple condition के साथ मैंने S plus as well as S minus and S naught को define किया हुआ है, right? So at the S plus we have phi of x minus phi star of x is greater than 0. For S minus, we have phi of x minus phi star of x less than 0, and S naught where phi of x equal to phi star of x or phi of x minus phi star of x equal to 0. Simple definition से मैंने three subsets को define किया हुआ है. As I said, these three subsets are the subsets of capital S, and therefore S is equal to S plus union S minus union S naught. That is nothing but this sample space. Now consider one integration over S phi of x minus phi star of x into p1x minus k p naught x d mu, right? ये हमें calculate करना है, ये integration. Of course, I am going to convert this integration into this form ultimately. That is, expectation of phi of x under h1 is greater than equal to expectation of phi star of x under h1. इसमें हमको convert करना है. But before that, we are going to consider this integration. Now, this integration is an integration of product between this bracket and this particular bracket. That is phi of x minus phi star of x into p1x minus k into p naught of x d. So we will consider this product first. We will check whether this product is greater than equal to 0, less than equal to 0, or equal to 0. Of course, we know the relationship on the basis of this S plus, that is phi of x minus phi star of x. If it belongs to S plus, then this bracket will be greater than 0. If it belongs to S minus, this bracket will be less than 0. Otherwise, it is equal to 0 if this particular x values belongs to S naught. So let us now consider the product of these two terms. Let us take first case 1. Here, let x belongs to S plus, right? We are assuming that the sample values belongs to S plus, that is the S plus is nothing but the subset of sample space. So if x belongs to S plus, according to the definition of S plus, we know that for such cases, phi of x minus phi star of x is greater than 0. That's what we have defined as far as S plus is concerned. So as soon as I say that x belongs to S plus, it means that phi of x minus phi star of x is greater than 0, right? Now please remember that phi of x as well as phi star of x are nothing but they are the test function. They are nothing but the probability of rejection. So we are going to use that particular concept here. Now when I say that phi of x minus phi star of x greater than 0, then phi of x must be greater than 0 because possible values of phi of x are 0 up to 1, of course. So out of that, phi of x equal to 0 is ruled out. Why ruled out? Let us see. That's what I have written here. Then phi of x must be greater than 0 because if phi of x is equal to 0, then according to this expression we have 0 minus phi star of x greater than 0 implies that phi star of x less than 0. And which is not true. As I said, phi as well as phi star of x being a test function, they are nothing but the probability of rejection lies between 0 to 1, cannot be less than 0, right? Therefore, we are here getting phi star of x less than 0. That condition we are getting because we have assumed that phi of x is equal to 0, and which is not true, and therefore we have to say that phi of x must be strictly greater than 0. फिर से देख लो, phi of x minus phi star of x is greater than 0, then phi of x must be strictly greater than 0, because if phi of x is equal to 0, then 0 minus phi star of x, इसके जगह मैंने 0 लिख दिया है, greater than 0 implies that phi star of x less than 0, which is not true since phi star is any other alpha level test function. This implies that phi of x greater than 0. So as soon as I say that phi of x greater than 0, just remember, the टेस्ट स्ट्रक्चर. कंडीशन बी अगर याद करो आप, उसमें है phi of x is equal to 1, phi of x is equal to gamma, phi of x is equal to 0. Phi of x is equal to 1 कब आता है? When p1x upon p0 x is greater than k. So when I say that अब greater than 0 आ रहा है, मतलब वो 0 नहीं हो सकता, less than 0 नहीं हो सकता, या any value lying between 0 and 1 नहीं हो सकता, right? Because it is strictly greater than 1. Let me show you that test. अगर आप लोगों को थोड़ा, so I am considering this test B, right? Now test B, right now the result that we got is phi of x greater than 0. अगर मैं greater than 0 की बात करता हूं, तो इसका मतलब क्या हो जाएगा कि ये दोनों वैल्यू फिलहाल रूल्ड आउट हो जाएगी, राइट? दैट मींस p1x अपॉन p0x. लेट मी शो यू. व्हेन आई से दैट phi of x ग्रेटर देन 0, जैसे ही phi of x ग्रेटर देन 0 आ जाएगा, इसका मतलब कौन सी कंडीशन रूल्ड आउट हो जाती है? वो थर्ड कंडीशन, phi of x इज इक्वल टू 0 इफ p1x अपॉन p0x लेस देन k. वो कंडीशन रूल्ड आउट हो जाएगी. यानी दो कंडीशन पॉसिबल है. वो कौन सी पॉसिबल है? p1x अपॉन p0x इक्वल टू 0 एंड p1x अपॉन p0x ग्रेटर देन k, राइट? सो on the basis of that I can say that this implies that p1x upon p0x greater than equal to k. यहाँ पे equal to चाहिए, okay? This implies that p1x minus k into p0x equal to greater than equal to 0, and hence the product of this particular bracket, that is phi of x minus phi star of x into this p1x minus k into p0x will always be greater than equal to 0 for all those values of x which belongs to s plus, right? So ये प्रोडक्ट ग्रेटर देन इक्वल टू 0 हो गया फॉर x बिलोंग्स टू s प्लस. ये कंडीशन क्यों आई है? बिकॉज रिमेंबर दैट phi of x will be equal to 1, phi of x will be a value between 0 and 1, and phi of x will be equal to 0. So when I say that phi of x is greater than 0, इसका मतलब है थर्ड कंडीशन रूल्ड आउट हो. दो कंडीशन बची है. वो दो कंडीशन कौन सी है? एक कंडीशन में वी हैव p1x अपॉन p0x ग्रेटर देन k, और दूसरी कंडीशन है p1x अपॉन p0x इक्वल टू k, राइट? सो ये दोनों कंडीशन का कॉम्बिनेशन मतलब p1x अपॉन p0x ग्रेटर देन इक्वल टू k. In other words, it means that p1x minus k into p0x greater than equal to 0. So ये bracket greater than equal to 0 आ रहा है. This bracket is strictly greater than 0. Therefore, product of these two brackets, that is this particular expression, will always be greater than equal to 0 for all those values of x which belongs to s plus. So this is case 1. Now let us assume that x belongs to s minus. Now I think you can also write down कि क्या होगा on the basis of this only. If I say that x belongs to s minus, now we have defined s minus. एस माइनस के डेफिनेशन के हिसाब से फाई ऑफ एक्स माइनस फाई स्टार ऑफ एक्स इज लेस देन जीरो. सो वही लॉजिक थोड़ा सा रिवर्स करते हुए वी विल ट्राई टू राइट डाउन वेयर x belongs to s minus. Okay, so let us take second case. Here x belongs to s minus. So according to definition of s minus, now we have phi of x minus phi star of x less than 0. Right? So according to definition of s minus. So as soon as I say that this particular difference, that is phi of x minus phi star of x, is less than 0, then phi of x must be less than 1. Why it must be less than 1? Because if phi of x equal to 1, this is the maximum value of phi of x. If phi of x equal to 1, then 1 minus phi star of x less than 0. क्योंकि यहाँ पे अगर मैं 1 पुट करता हूँ, then I will have 1 minus phi star of x less than 0, implies that phi star of x is greater than 1, which is not true, because as I said, phi star is any other test function, alpha level of course. That means it's a probability which cannot exceed 1, and therefore if we take phi of x equal to 1, we get phi star of x greater than 1, which is not true, and therefore we can say that phi of x must take a value less than 1. That means we have phi of x less than 1. So as soon as I say that phi of x equal to 1, now you know the three values of phi of x, possible values of phi of x. Phi of x can be 1, phi of x can be a value between 0 and 1, and phi of x can be equal to 0. अब phi of x is less than 1 जैसे ही मैं बोल देता हूं तो फर्स्ट कंडीशन रूल आउट हो जाती है, दैट इज नथिंग बट phi of x equal to 1. दैट मीन्स दो पॉसिबल सिचुएशन है, राइट? सो दैट situation can be expressed using this p1x upon p0x less than equal to k. लेस देन में phi of x 0 होता है एंड इक्वल टू में वो p1x इक्वल टू k हो जाता है. उस केस में phi of x is a value between 0 and 1. So therefore we can say that now p1x upon p0x less than equal to k. In other words, it means that p1x minus k into p0x less than equal to 0. So this bracket is less than equal to 0. This bracket is less than 0. Therefore, the product of these two terms, that is phi of x minus phi star of x into, in bracket, p1x minus k into p0x will always be again greater than equal to 0. क्योंकि वो less than है, दोनों negative term का product again greater than equal to 0 रह सकता है. So will be greater than equal to 0, right? So this situation again occurs for all those values of x which belongs to s minus. So for x belongs to s plus, this product is greater than equal to 0. Similarly, for x belongs to s minus, this product is again greater than equal to 0. Now one case that is remaining, that is nothing but this डिफरेंस इज इक्वल टू 0. ग्रेटर देन 0 देख लिया हम लोगों ने, लेस देन 0 देख लिया, अभी इक्वल टू 0, जहां पे phi of x minus phi star of x equal to 0. Now that is very simple, क्योंकि वो ब्रैकेट अगर 0 आ रहा है, naturally the product is going to be 0. Let x belongs to s naught. Now we have defined already s naught, so that is nothing but phi of x minus phi star of x equal to चाहिए यहाँ पे, हाँ, equal to 0. So if this bracket equal to 0 आ रहा है, then naturally the product, this product between these two terms, since this first bracket is 0, will be 0. Therefore, this product is equal to 0 for all those values of x which belongs to s naught. So case 1 में हमने देखा कि when this phi of x minus phi star of x is greater than 0, product is greater than equal to 0. Then in the second case, we have seen when phi of x minus phi star of x is less than 0, then again this product is greater than equal to 0. And in the third case, when phi of x minus phi star of x equal to 0, again the product comes up to be equal to 0. That means that integration of this particular product that product is always going to be greater than equal to 0. So from equation 1, 2 and 3 we have integration of this particular product over the range s plus union s minus union s dot s 0. This integration will always be greater than equal to 0. Now union of this is nothing but s, so that is what I have written. So this bracket, this product, integration of this product is always going to be greater than equal to 0. So now I'm trying to solve this particular integration. First of all, we will separate this. So you can see that first bracket multiplied by p1x d mu minus k into this bracket multiplied by p naught of x d mu. सिंपल इंटीग्रेशन टर्म को मैं सॉल्व करते हुए जा रहा हूँ, यहाँ पे सेपरेट कर लिया. In the end, you can see that on the left hand side I have a term related with the p1x, and on the right hand side I have a term related with the p0x, right? So this is the expression that we got. You can see that this expression left hand side is greater than equal to k into right hand side. Now just observe these terms also. इसका मतलब क्या है, इसका मतलब क्या है, you can also tell me. This p1 gives us the true distribution. Phi of x is nothing but the probability of rejection. So on the basis of this also you can write down whether this is a correct decision or wrong decision. ये हम लोग यहाँ से भी deduce कर सकते हैं. Of course we need to find out the power, right? So पहले उसके तरफ जाएंगे. Now let me show you again this. Just observe this integration. The first integration inside the bracket on the right hand side. As I said, P naught gives us the true nature of the distribution. So जैसे ही मैं P naught बोलता हूँ हम लोग बोलेंगे H naught is true, और अगर मैं P1 लिखता हूँ तो वो हो जाएगा H1 is true. So here we have P naught, that means the true density of the true density, in other words H naught is true, and this is nothing but probability of rejection. In other words, this is nothing but the expectation of phi of x under h naught. अगर इंटीग्रेशन ही है, इसका मतलब है वो इंटीग्रेशन का मतलब एक्सपेक्टेशन. सो एक्सपेक्टेशन ऑफ phi of x under h naught. Similarly, this is nothing but expectation of phi star of x under h naught, right? So इसके जगह मैं expectation लिख सकता हूँ, इसके जगह भी मैं expectation लिख सकता हूँ. This is expectation of phi of x. This is nothing but expectation of phi star of x. According to condition A, expectation of phi of x under h naught is equal to alpha, and we have assumed that phi star x be any other alpha level test. That means expectation of phi star of x under h naught is always less than equal to alpha. That means this is alpha, this value is less than equal to alpha. Naturally, the difference will always be greater than equal to 0. So that is what I have written here. You can see that expectation of phi of x is equal to this first term on the right hand side, and this is the second integration on the right hand side. So you can see that expectation of phi star of x is less than equal to alpha, and expectation of phi of x is equal to alpha, right? So we can replace, if this value is equal to alpha, this value is less than equal to alpha, that means this difference is always going to be greater than equal to 0. That means the right hand side of this expression is always greater than equal to 0. So I can write down this expression as this integration minus this integration greater than equal to 0, right? So this integration minus this integration is, you can see here, this left hand side is greater than equal to 0 मैंने बताया. Then it means that I can take this expression having a minus sign on the right hand side. So the resultant expression is integration of phi of x into p1x d mu greater than equal to phi star of x into t1x d mu। ऑन द सेम लाइन, ये जिस तरीके से लिखा हुआ है वैसे ही हम इसका भी एक्सपेक्टेशन लिख सकते हैं। दिस इज अगेन एन एक्सपेक्टेशन ऑफ आई ऑफ एक्स बट अंडर h1। दिस इज अगेन एन एक्सप्रेशन for expectation of phi star of x under h1 again. That means we have expectation of phi of x under h1 greater than equal to expectation of phi star of x again under h1. Now this is nothing but power of test phi, and this is nothing but power of test phi star. So the resultant expression is power of test phi is always greater than equal to power of test phi star. In other words, we can say that test phi is having a maximum power among the class of all alpha level tests. And therefore, we can say that phi is more powerful than phi star. But we have considered, or we have taken phi star to be any other alpha level test, and therefore by definition we can say that phi is more powerful than any other alpha level test, or we can say that phi is most powerful test. And we have assumed that phi, a test phi, satisfy condition A and condition B. In other words, we can say that test which satisfies equation A as well as equation B, or condition A and condition B, will be most powerful test. So that is nothing but the necessity sufficiency part of this particular test, right? So existence part में हमने सिंपली प्रूव किया था कि टू test simple hypothesis against simple alternative, a test having a structure given by condition A and condition B exists, वो existence part में हो गया। sufficiency part में हमने प्रूव किया है कि if any test satisfies condition A as well as condition B, then it must be most powerful test, right? So that is nothing but sufficiency part